Okay, so the purpose of this lesson is we're trying to answer the question. If matter cannot enter or exit a closed system, how does a liquid in the system change temperature? So up to this point in our unit, we figured out a few things that are important to understanding how the cup system works. There's some questions I want us to reflect on. I'm going to be reading them out loud. As I read them out loud, think about how you would answer them. What have we learned about cup systems? What questions can we now answer on our driving question board? How did we figure out answers to these questions? What do we still need to figure out? Thinking about what we've learned so far about cup systems, there's a variety of things that you could share. One thing that I just want to point out is our difference in definitions between a closed system and an open system. Remember, although it's really hard to have a completely closed system in the real world, a closed system says that matter cannot enter or exit our system freely. Whereas in an open system, matter is able to enter and exit as it pleases. As we're thinking about our driving question board, let's look at some of the questions you guys came up with. So here's our driving question board. So I want you to pause this video and think about what questions can we answer on this list? Okay, so we might not be able to like specifically and fully answer any of these questions, but there are definitely questions on this list that we can answer. I think about the first question that says, why does condensation form on the regular cup, but not on the fancy cup? We did two experiments previously to learn that condensation is coming from water in the air outside of the cup. We did a food dye lab where we colored the water inside of the cup and we saw the condensation on the outside was not colored. Therefore, this water must be coming from some place that's not inside of the cup. Additionally, we did a mass lab with this and we saw that the mass increased. Thus, our water vapors or our water molecules must be being added to our system, so they weren't originally a part of our system, making the mass increase. I also think about the question that says, how do straws, lids, and seals change how well the cups keep water cold? We've done a lot of experiments with lids. We know that when there is a lid on our cup and we have a relatively closed system, the water temperature is going to be more stable. Therefore, if we have hot water, it's more likely to remain hot. If we have cold water, it's more likely to remain cold. Thinking about the hot water, we know that when water warms up, it starts to evaporate. And if we don't have a lid on our cup, those evaporated water molecules will escape and somehow cool our water down and make the water decrease within our cup. When we think about what we still need to figure out, we still don't really know about what's driving this temperature change. We have identified that when condensation occurs, typically we have a cold surface meeting a warm surface, but we really don't know why this is happening. So I want you to think to yourself for a second, what else could be causing the temperature of the liquid inside of the closed cup system to change? And what else could possibly be going into or out of our cup? If you're having some time to think, we know that if this is a closed system, matter is not going into our cup, matter is not going outside of our cup. And so, therefore, we have to think about things that aren't matter. And one thing that comes to mind for me is energy. I know that you guys have heard of the term energy in your previous science classes. And when I'm thinking about energy that could possibly affect our cup, I reflect on our driving question board, and I know that some of you had questions regarding how light and how heat could impact our cup. So let's take a second to think about how light and heat could be affecting how the temperature changes in our cup. Today, we're going to be drawing two models. Now, as we have done previously, our models need to be detailed and they need to communicate to other people what we're thinking. These are some initial models. We don't know a lot about heat. We don't know a lot about light. However, I want you to get ideas down. I don't care if they're right or wrong per se. What I care about is that you're expressing your ideas and you're thinking about how these ideas are impacting our cup system. So let's think about some guiding questions that can help us before we dive into creating our models. So for light, think about how does light interact with different materials? So how could shining light on a clear plastic cup be different than shining light on a metal cup? How might light shining on a closed cup system cause the liquid inside to change temperature? So we know that this liquid inside is changing temperature. Could light somehow be contributing or be a factor influencing the temperature of the liquid inside of our cup? And then as we're thinking about these two major questions, how are we going to represent this in our model? Remember, I love labels. I love arrows. Make sure we're making things specific so that people understand where we are coming from. So the light will be one model. Another model that we're going to create is for heat or cold. So think to yourself, how does heat move? Where is the heat coming from? Where does it go to? How does cold move? Where is the cold coming from? Where is it moving to? How might heat or cold cause the liquid inside of the closed cup system to change temperature? So, what could be the effect of adding heat or adding cold? And how does this influence the liquid inside of our cup? And again, we connect this back to our model. How are we going to represent our ideas in our model? So this is the model that we're going to be working on today. Please make sure you put your name at the top of the sheet of paper so that way I know whose amazing work I'm looking at. This is our initial cup system models for talking about energy. The main sources of energy we're focusing on today are light and heat slash cold. So we're going to use these two models below to show how you think each of these ideas interact with our closed cup system and how those interactions could cause temperature of the liquid inside the system to change. So we're drawing two models. The one over here will be to represent how light is interacting with our cup. The one over here will be to represent how heat and cold is interacting with our cup. I have some pictures of cups for you to draw on. Now, one question that I've been getting a lot is, Mr. Maiman, I don't think there is a difference between a model for light and a model for heat. And if that is how you're feeling right now, that's totally fine. I want you to express what you think is happening with these two key ideas. But think about heat and light. Does it always have to be light out for there to be heat? Does it always have to be warm? Does there always have to be heat if light is present? How can we show differences and maybe even some similarities between our models? Now, if you are confused and you're like, I have no clue where to start on this model, I do have a checklist below to kind of guide your thinking. So, first, think to yourself, have you labeled all of the parts and components and have you listed and labeled them in your model? Think about, do you have the liquid in your cup? Is there any way that you could show particles? Additionally, the whole purpose of this model is to talk about light and then heat slash cold. So have you represented light in your model? Do you have heat and cold represented in your model? If not, that's something you need to add. And then here's the important one. We can label things, but we want an explanation. Do you have an explanation? I don't care if it's right or wrong. That shows how the light or the heat and cold are interacting with parts of our cup. Now, when I say an explanation, I don't mean that you need to write out a paragraph. What I'm asking you to do is to create a drawing that explains how the light is interacting with the cup. Draw a model or have a drawing that explains how heat and cold are interacting with different parts of the cup. Again, I don't care if this is right or wrong. I want you to get some ideas down. So as you're finishing up with your models, here's what I want us to do next. I want us to take this a step further. I want us to make a claim to answer the question, how do you think these ideas are causing the temperature of the liquid inside of our cup to change. So you can either write these claims down in the space below, or if you don't have enough room, you can flip your piece of paper over to the back. So we're focusing on addressing the question, how do you think this type of energy causes the temperature of the liquid inside of a closed cup system to change? Now we can make claims, and if you just want to throw an idea out there, that's fine. But also think about, what evidence do you have to support your claim? This evidence could come from things we've done in class so far, or it could come from your personal experience. So take a second right now to write a claim, answering the question, how do you think this type of energy is causing the temperature of the liquid inside of the closed cup system to change? In our next couple lessons, we're going to be doing experiments in order to understand the interaction between light, heat in our cup system. Hopefully, we can experiment with some different materials so that we can kind of bring our model to life. And I'm hoping that you guys can bring some of your personal experiences and your background ideas to add to our conversation.